All right, grade nines, let's finish up the content for this week. We have the next concept is called collinear, meaning that points are on the same line. So points are said to be collinear if they lie on the same line. If this is the case, the slope of the line between each of the points will be the same. Determine if the following sets of points are collinear. So they have a point A, a point B, and a point C. And so the key here is that you need to connect point A to point B with a slope, and then point B to point C with a slope. And if AB has the same slope as BC, you have a collinear line. So let's take a look at what that might look like first with a visual, and then we'll do the mathematics using the slope formula to solve and confirm if points are collinear or not. So basically what it's saying is, if you had a visual, you'd have, say for example, there's your axes, you've got your x-axis, you got your y-axis, and you have a point and a point. And this is going to be A, and this is going to be B, and say there's another point C. So you got A, B, and C. The idea is if this slope right here is the same as BC, this slope right here, if they were the same, they'd be on the same line. As you can see, AB has a different slope than BC, so they will not be on the line. But if we change that, and we had A, B, C, say you had those 3 points and you calculated, you might find that the slope AB and slope BC are the same, and therefore the entire line is on the same line, or it's collinear. All the points are on the same line. So that's what we need to figure out. And the first points we have are negative 4, 11. That's A. 0, 3 for B, and 9, negative 15 for C. So there's my 3 points. And I need to come up with slope equations for AB first. So I'm going to do A and B and connect those two. And once I've connected those two, if I can do B and C and connect those two, and if they both have the same slope, then A and C will have the same slope. So I've basically connected them all. But first, we'll do A and B. So negative 4 and 11, 0 and 3. And my slope equation, you'll remember, is y2 minus y1 over x2 minus x1. There's my slope equation. And I just need to decide which point is 1 and which point is 2. So again, I have A and B. And let's just call A1 and B2, just for argument's sake. So we have A1 and B2. So there's always X and then Y. And I have XY for B2. So that's going to be a 3. So my very first Y2 is a 3. Y1 is a 11. So 3, y2, y1, 11. Now we need x2 is 0 and x1 is negative 4. So 3 minus 11, 0 minus negative 4. Remember 0 minus minus 4. So 0, 2 negatives going in succession. That makes it a positive. So that's going to equal 3 minus 11 is negative 8 over 4. negative 8 over 4, or another way of putting that is negative 2. So negative 2. Done. So from A to B, we have a slope of negative 2. Okay, so there's my slope. My M is negative 2. Now what I want to find out is if B and C have a similar result. So let's look at B and C now and see if we have a similar result. So we're going to call C point 2 negative 15 minus 3 over 9 minus 0. So again, 0, 3, that's x and y. We're calling this point 2, this point 1. y2 is negative 15, and y1 is 3. So negative 15 minus 3 is negative 18. And 9 minus 0 is 9. 18 divided by 9 is 2, and it's negative 2. So that slope is negative 2. So AB is negative 2, BC is negative 2, and if you wanted to, you could check AC and confirm it's negative 2, but you already know that it should be, because AB is negative 2 and BC is negative 2, so extending that idea, the whole thing, A to C, should be negative 2. You can check it, but once you have AB and BC done, you've essentially solved the problem already, and it's negative 2, so it is on the same line. But let's just, for argument's sake, try AC. So I want to go A to C. Well, I'm going to call C point 2. So that's going to be, again, negative 15 minus the A point was 11. And x is 9 minus negative 4. So negative 15 minus 11, 9 minus negative 4. So that is going to be negative 26 over 13, which is negative 2. So there's your calculations for AC. It is also negative 2. So the entire thing has slopes of negative 2. It is considered collinear. All you're doing over and over again is finding the slope and determining if it's collinear by having the same slope. And you're checking all the points. So there was A. Let's try B. We have X, Y, and Z. X at 7, 0. Y at negative 3, 4. And Z at 2, 6. So there's my 3 points again, X, Y, and Z. Let's try X, Y first. So Y2 minus Y1, same process, same ideas. We have 4 minus 0 over negative 3 minus 7. And negative 10. So there's my calculations. Good enough. That's fine. Let's check YZ. So now we're going 6 minus 4 over 2 minus 3. So there's YZ. We've got 6 as a Y2 right here. We've got 4 right there. And that's going to equal 2. And now 3 minus 3 is 5. which is also known as 4/10. So we do have equivalent fractions, but the problem is one is negative, the other one is positive. So they are not collinear. Just because they're the same fraction, positive, negative, that does not work. They are not collinear. So example B was not collinear. Okay, second example for today. A pool is being drained at a constant rate. After 30 minutes, the water is at a height of 2.2 meters. After 80 minutes, the water is at a height of 1.8 meters. Determine the rate at which the water is draining from the pool. So typically with a pool, you're looking at height versus time. So height versus time. The x is the time. So let's look at some of the values. 30 minutes is time. And at 30 minutes, the water is at a height of 2.2 meters. And then 80 minutes, the height is 1.8. So I've made my two values that the question gave me. So we had at 30 minutes, 2.2 meters, and at 80 minutes, 1.8 meters. Now I need to find my slope. That's determine the rate at which the water is draining. That's your slope. Slope is rate. So the rate of decline, how fast is this height going down based on the time? You know it's going down, just how fast is it going down? So there should be a negative slope. These are kind of things you could figure out just by listening to the question. So y2 minus y1, I'm going to go 1.8 minus 2.2 and 80 minus 30. So there's my values. I just randomly chose 0.1 and 0.2. Really doesn't matter. Just how it went. And that's going to equal negative 0.4 over 50. So you've got a negative 0.4 meters every 50 minutes. Now we could definitely change that to per minute. So essentially just divide by 50 to get the rate per minute. And you probably don't want to be in meters anymore. So you know that there's 100 centimeters in every meter. So we could convert this if we wanted to make it pretty and make it negative 40 centimeters per 50 minutes. And that might be a little better. So instead of 0.4 meters, you're looking at 40 centimeters every 50 minutes. If you wanted to, you could divide that by the 50 to get per minute. So if you wanted to know a per minute relationship here, so you've got negative 0.8 centimeters per minute just by dividing. So negative 0.8 centimeters per minute for that particular question.